Good morning, everybody. Still good morning. So let me explain how to do the gRPC-based application development using ASP.NET Core 3.0. So you know that Microsoft has recently released ASP.NET Core 3.0, and together with that, they have released quite a lot of new technologies. One of them is gRPC support. So first, I'll explain the messaging, the history of messaging, and what the gRPC is, and then explain you how to develop gRPC applications using .NET Core 3.0 and Visual Studio. Sorry. So let's speak about the history first. So there are different technologies used throughout the history on enterprise communication. Initially, we started with asynchronous messaging and batch processing. Like when we had these initial mainframe servers, or the initial days of computing, basically enterprise communication was basically based on asynchronous messaging and batch processing. Basically, what they have to do is they will share some files, basically mostly text files, from one system to another, and then data is shared between them, right? Then they started something called remote procedure calls, so RPC, right? Where you call a method in a local stub class or object, and that method will in turn call a invoke a method in the remote system. So basically what will happen is that you serialize the data, that is the information that should be passed to the method, and send it to the remote server, and remote server will deserialize it and execute whatever the command you send, and then the response comes back, and you will feel like you're calling a local method, right? So that's called remote procedure calls, or RPC. So that is the next level of evolution in the distributed application development. So rather than asynchronous messaging, they started what they called RPC, or remote procedure calls. Then with the object-oriented program becoming popular, they were not satisfied about RPC. Like RPC is like procedure calls, which doesn't maintain state. So people wanted, when they start using object-oriented programming, they wanted to be the distributed application development also to be object-oriented. Therefore, they turn into something called remote method invocation, or RMI. Right? What that means is, like you instantiate a remote object in a remote server, and then you pass the messages to that particular object and keep sequence of messages. And once you're done, you destroy it or dispose it. So then, like what you will have is something similar to object-oriented programming paradigm, where you create an instance. What you are really doing is creating a stub instance, and then sub instance will keep a reference to the remote server instance, and then maintain that instance. You send a message, and you get the response like that. And once you're done with it, you have to destroy the remote object as well. We're not destroying or disposing the local object or the stub or proxy, whatever you call it. It will destroy the server object as well. Like that is the RMI. Then synchronous document-based messaging, like basically document, XML document or JSON document-based messaging, which was popular as part of SOAP. And then finally REST, which we use every day, right? So now I am speaking about gRPC, which is going back to the second level of evolution. Like we'll see why that change is there and how this change happens, right? So, like we need to understand again the serialization. Initial days, people use binary serialization. So binary serialization means you have the objects in. So basically, what serialization means, you have the objects in memory. You want to convert it into a byte array, which you can transfer to a remote server, or you can save it in a local hard disk or somewhere, and you can load it back, right? And create the same in-memory object that you had. Right? So whenever that enterprise communication happens, like if you want to communicate between two processes or two applications, or maybe remotely or in the same machine, you have to serialize it. Why? Because the concept of memory can, even though it's even the same machine, the data can be accessed only if they are in the same address space. So in computers, like for information security purposes, applications, operating system gives certain address space for each application. So that application can access only memory belongs to that address space, or the application is a process. Always handles things as processes, so that process can address only the objects in that application. So if you want to communicate or send data from one object to one application to another, or one process to another, maybe the same machine or in a remote location, you have to convert it into byte array, then transfer it, and the other side you have to convert it back to an in-memory object, right? So one way of converting byte arrays, you can convert it into just binary numbers, ones and zeros, or you can convert it to text file, text message. So the advantage of text messages is they are more readable, right? Everybody, like you can open it and see what's there, whereas the binary messages are very compact and serialization is very much more efficient, right? So now, like initially, like early days, there were lots of serialization formats. So these are the popular serialization formats that we use today, binary serialization formats: protobuf, thrift, message pack, and Avro, right? So protobuf was invented by Google, which is the basis for GRPC. Like we'll come to that later. So the advantage of these binary serialization formats is, like, they are not the earlier binary serialization that we used to have with maybe .NET remoting or Java RMI. So they are modern binary serializations. They are extremely efficient and compact, really fast, right? So the differences between them is both protobuf and thrift is based on strongly typed schema. Like, so your application should know about the message schema beforehand to process it. Like the schema information is not included in the message. So you serialize some message according to a certain schema. From the other side of the application, you should have the schema information to deserialize it and process it, right? So protobuf was invented by Google, and the thrift was invented by Facebook. And then message pack is exactly the opposite of it. It's like JSON. Like JSON or XML, for example, XML has certain schema, but it can go without schema as well. JSON normally doesn't have a schema. You can put anything as set of key value pairs and list arrays, right? So message pack is like JSON, where you don't have a particular schema. So that, say, if you have a JSON message, to understand the JSON message, you don't have to know the schema. You can see what are the properties of JSON object, and inside that what you have. You don't need to know the schema to understand JSON. Then you can open it and see. Whereas if it's a message pack, even if you can open it, you still can't know what it is without knowing the schema, because they are just numbers. Whereas here the keys are also present. So message pack is a binary format of binary form of a kind of JSON, where you have the key values, but it's a compact and more efficient format. Like a good example is where you use message pack is in SignalR in .NET Framework 3.0 SignalR version, which I'm not going to cover here. Also use message pack. The reason is it is much more compact than JSON, even though it looks similar to JSON. Like it can be used as a drop-in replacement for JSON. Okay, it has same characteristics. And Avro is another format. What is different about the Avro is the Avro message has the schema within the message itself. So we've had the message schema and then the message. So it's similar to message pack in that you don't need to know the schema beforehand, but it's in other way strongly typed because you have the schema also together with the message. So those are the binary formats that is widely used today. All of them are open source, and almost all the platforms, including .NET, Java, Python, Ruby, all that platforms has implementations for all these message formats, libraries to serialize and deserialize. And then text-based serialization, like the CSV, comma separated values, or TSV, tab separated values, or some kind of delimiter and set of values. It's the most popular form of serialization used in early days of the computer, and still it's widely used to share data. So those are popular human-readable text formats, and XML and JSON. So those are the two alternatives. From them, like one of the advantages of these text-based formats over binary in early days was the binary formats were not standard. For example, .NET remoting used .NET Serialization Protocol, whereas Java was using Java RMI. And each protocol has their own serialization mechanism, which was not standard, so it was not compatible. But fortunately, all of these now modern binary serialization platforms, formats, are not like that. They are interoperable. Like every platform, be it .NET, Java, Python, C, C, whatever, all of them has Go, whatever, Rust or whatever, has implementations for all these serialization formats. So it's no longer a matter of platform tying up. Like they are not belongs to a particular company, even though ProtoBuf was invented by Google. It's open source thing. Like so, there's not no binding with Google. So they're platform independent, and any platform can serialize it, and any platform can deserialize it, and they're extremely efficient. So only drawback being you can't read it while in the serialized format. Like, and if you open a binary file, you can't see what is in it. Whereas if you open a JSON file or XML file, you can see what is there. So it's easy to debug. Other than that, the platform neutrality is now there in the modern serialization formats, binary serialization formats as well. Efficiency is also there. Right? So first, we'll start with asynchronous messaging, which is the initial thing we had. Started from early days. You have CSV, TSV, XML, JSON, anything. So it's disconnected communication there. So basically, we use communication protocols like initially file share. Like you copy a file from one file share to another. You can use FTP or network file share, NFS, or any protocol for doing that. Then people start using queues, like RabbitMQ or MSMQ or any queuing protocol can be used for asynchronous messaging. Like, so basically what you're doing is either you copy a file there so that let the other application process it, or you put a message to a queue and the other application can pick the message from the queue and process it. Or you can use publish subscribe patterns. Like rather than queuing, there are some message brokers like RabbitMQ or MSMQ, or there are lots of other Azure queue service or Amazon Simple Queue or something. There are protocols where you can publish messages and there can be many subscribers. All of them can receive it and process it. And ESBs, enterprise service buses, are basically also widely support asynchronous messaging. So basically, you do it using SOAP. You send a message, SOAP message, and it will asynchronously deliver it to another system which can process it. Right? In either way, like when you have messages, like there are 4 types of messages: commands, events, and batches. Like commands are the message where you have the intent, like what you, that's command, like something that you have to do with the message. And then the message body contains the information required to do that action. Like do a transaction, like transfer money from this account to this account. It's a command. Or like change the name of a particular person. It's a command, right? So it has a command and the required parameters. So unlike this RPC or other formats, here the command also is part of the message itself. Which means that you don't have to immediately run that. You can even save it somewhere, keep it for several days, and then get it and pick it and execute it. Because the command itself contains, the message itself contains the commands, right? And there are events. Events means information about something that happened earlier, like money is transferred, or a certain amount of money is deposited to the account, or certain person's name is or address is changed. So those messages also can be processed later. But those doesn't have the command. But anybody can process it in whatever the way they want, because it's something happened in history. It will never change. There's no requirement of validations. So any number of people can process it. Commands can be processed only by one person, one system, but events can be processed by any. So asynchronous, and the batches means a batch of events or batch of commands. Normally, in CSV files or text commands, what you have is batch of commands. Even like there's something called EDI, electronic data exchange, EDI messages, etc., contains batch of commands usually or batch of events. Then once you can share asynchronously and anybody can process it, right? It can be via ESB through SOAP or publish a subdriver like RabbitMQ or queues or file share like FTP location or a network file share NFS location. Anything like that can be used to communicate. Right, then the RMI. RMI was widely used during the initial days of object-oriented programming. Like they have the application servers. Popular, like lots of Java application servers were there, .NET remoting was there, and we have COBA, which is an open standard, and Microsoft had COM, which is DCOM, which is Windows only. COM is for within the same machine, and DCOM is to communicate across machines. Like all these protocols were introduced for strongly typed messages. So they also use efficient binary serialization, but mostly proprietary, like Java RMI use their own format, .NET remoting use their own format, COBA had their own serialization format, etc. Right? And simple OOP-like programming model. So those are the advantages. The main disadvantage is it has to maintain the session in the server, remote server. Like you create an object, and then that object has to be maintained in the memory as long as the client is using it. Now the disadvantage is not scalable model. You have to keep it connected, and every request, you have to maintain that object in memory. So every client is occupying a permanent amount of memory as long as the object is alive. So it cannot be scaled. Like, you can't be distributed. Like, because if one request comes to one server and another request comes to another server, if you have clustered, it doesn't work. All the requests has to come to the same server. As a result, this distributed object model, or RMI, is not scalable. That is why nowadays people are not using it. That is one big disadvantage. That is not scalable. That is why the application servers, the big applications are popular. They are like now no longer being used because RMI or .NET remoting is not scalable. Other disadvantage is they use proprietary binary serialization together with the port numbers, which is not TCP based. Sorry, TCP based, but sorry, not HTTP based. So the disadvantage is they are being blocked by firewalls. Now mostly only HTTP based ports, like HTTP and HTTPS ports, are opened by the firewalls. Because the other ports are used for operating system and security purposes, so they can be a security risk. Therefore, these kind of RMI-based implementations are no longer useful across the firewalls or across corporate network borders or LAN borders. Therefore, they are not very popular these days. Like, they were popular once there, but now they are no longer being widely used because they can't be used across the systems, across the networks, because of the firewalls. Right? Then we have the SOAP. Right? So SOAP has lots of good advantages, but one of the key disadvantages, so basically SOAP is sending XML messages over HTTP post request, only HTTP post request. But the XML is not arbitrary XML, you have to be it in a SOAP schema. Like, they have the SOAP headers, it has to be in a particular schema, and the schema is governed by what they call the WS protocols, WS asterisk protocols. There are lots of standards for SOAP. Like, initially SOAP stands for Simple Object Access Protocol, but later it's no longer simple, so they say that SOAP is SOAP. Like, so it's not an abbreviation because it's no longer simple now. It has lots of very powerful features, but the disadvantage of SOAP being it's difficult to process. Like, especially you can't process SOAP messages in JavaScript or single-page applications, etc., because they are so complex. XML files, it's difficult to process, so it's heavyweight. So people now no longer use SOAP either. So SOAP support both RPC-based communication and message-based communication. Like, you can have the big message with the command, it's everything embedded into it, or event. Or else it can have a RPC-style API as well. But SOAP, everybody who encourages SOAP, like especially ESBs, are discouraging RPC mode. They are, if you look at SOAP documents, like web service documentations, they are encouraging message-based mode over RPC-based mode. But if you look at earlier implementations, 90% of the SOAP implementations are RPC-based. Like, because natural developers think in terms of RPC, but people are encouraging, or architects are encouraging them to use message-based communication. Because the advantage of message-based communication is you can use it through ESB. And the ESB was a big business. So the companies like IBM or Oracle, WebLogic, etc., were encouraging people to use their ESBs. So they wanted to promote people to use the messaging-based format, but people were actually using RPC-style communication in SOAP, if you look at the real implementations. So later that SOAP was replaced. Then came JSON Web API. So JSON, again, like, you have two styles, REST style and RPC style. Right? So JSON-based, again, it's earlier like SOAP was essentially HTTP over XML over HTTP, whereas JSON or the JSON Web API is JSON over HTTP. Right? But differently, like, we don't have SOAP headers. It's basically based on the HTTP protocol itself. Like, if you look at REST or JSON way, you just have get, post, verbs, and then you don't have the header or something else. You just have the JSON payload, and you can have JSON headers. Sorry, HTTP headers, like authorization header to authenticate. So the difference between REST style and RPC style is, the REST style is based on HTTP protocol itself. Like, every resource has a unique URL, just like web pages. And then you invoke operations on it, get, post, delete, HTTP verbs, using HTTP verbs. Right? And you use hyperlinks to create links between two objects. Right? The advantage of this one is very nice, very well structured. Right? And it's very good for modeling a large domain, like if you want to query complex domain, different entities, etc., you can use it. And if you want to have strong typing, originally JSON didn't, or the REST API were not strongly typed. With the Swagger, or that what you call Open API, now it can be strongly typed. So you can have the schema defined, and you can auto-generate the clients. The advantage of strong typing is you can auto-generate the clients to consume the APIs, and also you can even create the client even before you develop in service, because you have a schema or the contract defined. Right? So that advantage is there with, like SOAP has that, like you have WSDL. So why? So this is called, actually these kind of languages are called interface definition languages, or IDLs. So SOAP has the WSDL, where you define what are the methods, what are the inputs, and what are the outputs using this WSDL. So SOAP has the advantage of ability to auto-generate the clients, whereas initial REST implementation did not have that. Why? Because REST initially is not strongly typed, it's weakly typed. So you can't auto-generate the clients. That is why this Open API or Swagger came. With that, like now you can expose the metadata of a JSON or REST API over Swagger file, so it's another JSON file, so that you can auto-generate the clients, you can validate if the schema is correct, and etc. Yeah, so that advantage is in JSON as well now. But those REST APIs are widely popular, but if you look at real implementations, just like SOAP, 90% of the real web API implementations are JSON over RPC rather than RPC style JSON API rather than REST APIs. Because like the advantage of RPC API is interface is based on the business operations or business intent. So you get an post over. So if you have purpose-built APIs, like if you don't know what the API is going to be used for, and if you just want to expose information, the REST is the best approach. But if you know what you are using for, say I am building my application, I am building my client, then this RPC style of web API will give the best performance, best lesser effort, etc. So people end up building RPC style REST API, JSON API, JSON Web API, not the REST API. You can't say RPC REST API, so JSON API rather than REST API. Why? Because it will more closer to the application, and you can give better performance because it's purpose built. Whereas the real REST style is good when you want to, if you don't know what your information API is going to be used for. If you want to expose all the features of your whole business domain, kind of applications where REST will give give better way of exposing our information to the world. So practically most of the applications are really. So for example, if you want to do transaction, in RESTful way of doing it is, say you have the accounts / account code / transactions and put a post request. It's as of like you're adding a transaction to the transactions list. But really as a side effect, the money will be transferred from one account to another. Or money will be deposited or withdrawn. So the real business function will be a side effect, whereas what you're trying to do is you're adding a request or you're adding a transaction request. It's what you're doing in the REST side. Whereas in REST, this API, RPC style, the business function is the key effect. Where the data getting modified is a side effect. Like you do the transaction, as a result, you get the transaction added to the transaction history, etc. is a side effect. So the key difference is between RPC style and REST style is that. So REST was become popular because it's closer to HTML, so it's HTTP protocol. But the reality is, it's not very closer to the way that developers think, and performance-wise, you can get better performance with RPC style. So let's talk to GRPC. So it's again simple request response based RPC protocol. APIs are modeled on business operations, just like what we are doing is stop RPC silo. So far, like we call something like REST and we implement RPC, or we call something SOAP and we are messaging based, but we are doing RPC. But now we are calling it RPC and doing RPC, right? That's the key difference in there. Since the disadvantage of remote method unification, where you have to maintain state, is not there. It's just stateless. So contract first means just like SOAP has WSDL and JSON has this Swagger or Open API. This also has Google's ProtoBusIDL, what you call interface definition language, to define the interface, so it's strongly typed. So you have the client-side object model. You can, because it's strongly typed, you can auto-generate the clients. So it's a matter of method calls, just like SOAP WSDL calls. So Microsoft has very rich support for that. So you can just use the auto-generated stub. That is another advantage. And it's based on GRPC is based on Google's protocol. There is Google's protocol called GRPC. It's actually protobuf over the HTTP2, right? This is about the RPCs. So RPC, like in RPC, you have XML RPC, JSON RPC, and then you have the binary protocols like gRPC, Apache Thrift, Apache Avro. All of them are RPC protocols. One is gRPC from Google. Apache Thrift is the Facebook implementation of a RPC protocol similar to gRPC. It's like kind of competitor where you can compare both as similar implementations. But the advantage if you .NET, the gRPC has better support from Microsoft. Other than that, both are very similar. And Apache Avro is another open source implementation of RPC protocol, which is basically more useful for dynamic languages, etc. But they are like similar products. Right? So if you take gRPC in particular, the key advantage of why gRPC is popular these days is because HTTP2, like is second generation of HTTP. The HTTP 1 or 1.1 rather is very good for text-based communication, but it's not optimal for binary communication, right? And also it's not good for streaming because it's designed for different purpose, like to support web pages. Whereas HTTP2, which is basically built by Google as a SPDY, and then SPDY protocol was now renamed as HTTP2 with the standardization, is optimal for binary communication. Therefore, it's a new way. It opened up because that is why SOAP and HTTP REST both are text-based. But now it opens up a new avenue for us to use efficient binary communication of HTTP. Otherwise, like if you have binary communication, you have to convert it to base64 encoded, which is like killing of all the performance. Like why we use binary communication is to do efficient communication, and if you have to convert to binary and then base64 encoded, then come back vice versa, it will not be very efficient. So this is one of the key reasons. HTTP, only reason for HTTP is not binary, like it is efficient web page rendering, but side advantage is it is very good for efficient binary communication and streaming and long connection handling. That is one reason. And the connection handling, everything is optimized with HTTP2, so it gives us a good avenue. And protocol buffer or protobuf is a very efficient serialization protocol from Google. So both together, HTTP2 and protobuf together gives an extremely efficient mechanism which is interoperable, supported by all the platforms, stateless, and open through firewalls because it's HTTP2 based. So obviously it has to be opened, otherwise most of the websites will be blocked. Modern websites, including Google, support HTTP2. So nobody will block HTTP2. So that is the key advantage. It has advantages of both, like binary serialization, efficient serialization, so it's extremely efficient. The only disadvantage currently being, you don't have good support from JavaScript, so you can't use for single page applications. But if both client and server are either .NET, Java, or whatever other thing, the gRPC provides the best way of inter-process communication currently, because it's efficient, not blocked by firewalls, very scalable. So you have advantages both ways. But the disadvantage is still you don't have good implementation of JavaScript. Like so, if you have JavaScript clients in, what I mean is not the Node.js JavaScript, the browser JavaScript. If you have browser-based JavaScript, then REST will be the REST or whatever JSON RPC will be a best alternative. But gRPC is with then messaging patterns. Like it supports both request response streaming, response streaming, and bidirectional streaming. So security-wise, because it's HTTP based, you can use same HTTP headers with the gRPC messages. So same OAuth2 or any other protocol secure protocol that we use to protect REST API or REST RPC can be used here also. Like it can be cookie based or HTTP header based. So it all works, right? So it's stateless, and because it's efficient binary serialization, it consumes very less bandwidth, right? And you can have long-running connections as well, right? So those are the key advantages of HTTP or the gRPC, because the security-wise it's same, implementation-wise it's very similar. So basically, all you need to learn new is this new protocol, new language called IDL, or Interface Defined Language for protobuf. Like this is a sample code. So if you understand it, like you say that its syntax is Proto 3, which is the third version of protobuf, is the version 3. And this one is to import if you want to have some predefined types, like for time. Timestamp is a predefined type in Google. So you can import like that. So if you don't have timestamp, you don't need to add it. Timestamp or timestamp is equal to date time in .NET and Java. Right? And then these are options. Like if you want to serialize it in .NET, this is the .NET namespace. Like you can say if Java, like what is the Java package, or if Go, like what is the Go namespace, etc. You can give some options. Those are additional options that will be implemented based on the platform during the code generation. Like because these are the intention is to generate the code for both client and server. Right? So when you have protofile, you can auto-generate the code for both client and server in .NET. And then the messages. Right? And these are the strong types, these things. In 32, string, etc. These data types are listed in, I'll show you this Google, if you get Google Protobuf documentation, you have all of them. And repeated means it's a list or array. So if you want to have the list of roles, now this same employee has list of roles, repeated roles. So here you have the role object, which has ID and the name. And here you have a number, 1, 2, 3, 4, 5. That number indicates what is the field ID. It looks a little bit confusing because equal sign is used, but rather like you should use a different symbol, but it means ID is the first field, first name is the second field, last name, etc. Why that is used is, whenever you serialize data, they serialize it as one is this value, 2 has this value, etc. They don't put this name, ID, first name, etc. So when you are invoking it, the other side also should process it in the same order or same way. And if some fields are null, they don't consume space because they don't have to, because they know what is 1, what is 2, what is 3. So even you have unused ones, you don't have to consume the fixed space because you know what 1, 2, 3. And the other advantage is when you come to versioning. Like if I want to add if I want to remove certain field and add another field, you can't reuse the existing number in your contract, because then what happens if you do that? Then if there's an old schema, if a message that is generated in the older schema and if you deserialize it a new schema, you will get the number deserialized wrongly. Therefore, you can always add a new number and remove existing numbers, but never reuse the existing numbers because it will break the versioning. So you want to support versioning. That is why this 1, 2, all these numbers are there. So if I want to have something else, you add a column. If you want to remove it, you just delete this. So you never use the existing numbers. As long as you never use the existing numbers, the new, just like JSON, if a field is missing, it will just missing. It will not be serialized. It won't break anything. So the version compatibility is guaranteed if you do that. And having additional column will also not a problem if your contract doesn't have it. Right? So this is how you use gRPC for serialization and deserialization. Like you just can create a file. So all you need to do is you have to add references. If it's, unfortunately, I was prepared to do some hands-on samples, but Visual Studio is not working due to some technical issue here. So I can't do it here, but the code is there. So all you need to do is you have to add reference to these NuGet packages, Google Protobuf, gRPC tools, and gRPC client. So gRPC tools is actually not the code that you will be included in your final compiled code, but it's a code generated tool, NuGet package. So when you have a protofile in your project, this gRPC tool project will automatically detect the protofile and compile and create the server or client based on the configuration. Auto-generate this one. That is why this gRPC tools is important. It is not being used. And whatever the client libraries that we use here are coming from this .NET gRPC client, gRPC .NET client package. And once you have these NuGet packages, you can serialize it. Like, so when you have this one and the previously shown protofile, automatically it will generate employee class and this toWrite method or fast method, all of them are auto-generated. But the implementations are there with the other package, gRPC.NET client. Right? So once you have it, you can serialize the data like that and deserialize it like that. So it's extremely, you can compare, actually, if I had, I should have shown you, like it is about 10 times smaller than equivalent JSON. You can just try it out and see. You can get a complex object like anything, and you can use GRPC and serialize it and see it, and do the same object serialized with JSON. It's about, minimum it's double, based on the object size. Minimum it will be double, the JSON will be double size. Sometimes even it's 10 times bigger. Right? So you can see it's extremely efficient. And then GRPC not only support the contract, the data contracts, it also supports service contracts. You can define a service. A service like, so this is the package name, and it will be Java package or class, and the greeter, and RPC say hello. This is the request object type, and this is the response type. Request object is here, and the response object is here. Right? So we are defining a service endpoints. It's a matter of just defining request and response. Right? So the consuming is very simple. You create a Visual Studio GRPC type, or you add the reference to this one. Visual Studio itself has a template. You can either use that template, or .NET Core has a template, or else we can use GRPC, add reference to this one, and add this code in your configuration service file, and add this code in your what you call startup.config file. So all that is what you need, but there's a template. That template comes with it, so you don't even have to do that. Okay, so time's up. Okay, so let me quickly stop it. So this is how you are the client. So you express service, and you add the references to this, and you have all this code auto-generated for you. All you have to do is to call the service method with the GRCP. And if you want streaming, you can define this as streams. The difference only between the stream is you can have many requests for one connection, or many responses to one connection, or both. If you put stream, you can send stream of future. I just show a quick example. Here, a service like you get multiple requests. Like a good example is when you want to show the progress. Like if you have a long-running operation, you get one request. While you're processing, you can give the response progress and finally the results. If you want to do that, then streaming is a good option. Or you want set live updates, cricket match results, or etc. Streaming of GRPC is a good choice for that. So that is what I wanted to cover. This is how the service implementation for that, and this is the client implementation for that. So sorry for the technical issues and the delay. So if you want to have questions, you can either write one of these emails, and you have references here. The GRPC, first one is from Microsoft ASP.NET, and the other one is the GRPC, and the other one is Google's thing. So any questions? I hope you understand what the GRPC is, and why the world is moving towards GRPC, and why Microsoft is promoting it being the Google technology, and why it's getting popular. So if you have any questions, please drop an email or talk to me. Thank you.